On Ex's Slip 711, our job is to be able to match graphs with real world situations. We've been graphing different things, and a lot of the graphs we've seen have been the straight lines because there's been a constant rate. So let's look at some different situations here and we understand which graph goes with it. So if we're looking at the length of a boy's hair during 1 year, if I look at this graph, I see on graph A, it goes up like it's growing. Okay, and then it looks like it goes down and it goes up at the same rate, and it's coming down, it goes up at the same rate. To me, that looks like a haircut because your hair gets so long, and then usually you get a haircut, right? And it gets back down shorter, okay, and it grows at the same rate. So notice the lines are going up at the same rate, okay? So that one could represent a haircut. And if you look at the other ones, you're seeing these are going up the whole time, so I don't know where there'd be a haircut, right? Where it gets shorter again and go down with the length of the hair. Okay, and this one kind of looks like below something, so that's not making a lot of sense. So graph A would match that situation. Graph B, the elevation of a hiking trail that starts below sea level and goes to the peak of a mountain. And graph C sticks out for me because below sea level, it's below this line here, and then it keeps going up to the peak, gets up to the top, and that looks like where it stops. So graph C matches up with that situation. And notice it doesn't go up at the same rate because we know on a mountain it's not the same rate of increase all the time. It's kind of flattens sometimes, and sometimes it's a little steeper, so that would make sense. Question C, the height of a whale that jumps out of the water. And this one to me looks like that would work because, again, it's underwater, so it's down below. It jumps above, and then we know the whale will come back down and land in the water and eventually would go back under too, right? So it jumps out of the water. This is just showing him out of the water. Okay, that would be D. And then the last one, an athlete's heart rate from the beginning of a workout. Okay, so if I go to graph B, is the only one left. So would this represent his heart rate at the beginning of a workout? So here would be where his heart rate starts. And as he's working out, it's getting gradually starting to grow and increase. It's getting faster and sometimes steeper than others, but it's always going up because as he's working out, his heart rate's picking up, so it keeps increasing. So I would say graph B does a pretty good job of representing how that could look. All right, there are all kinds of situations, and the graphs would look different for all of them in real life. This is just a sample of a few, and can you match certain ones with certain situations with your knowledge of what these things mean and how I could translate it into a graph.